All right, let's be real. Every factory, every single production line is going to have problems. It's just a fact of life. But the real question is, how do you take some random defect that pops up and turn it into a permanent solution, one that never comes back? Well, today, we're going to break down two super powerful tools that work together to do just that. The Engineering Problem Report, you'll hear it called an EPR, and the 8D problem-solving process. Okay, so picture this, right? Production is humming along, everything's going great, and then bam, an inspector finds a critical defect. Suddenly the line might have to stop, a customer shipment could be on the line. What you do in the next few minutes, the next couple of hours, it is absolutely crucial. So, to make this all feel a bit more real, let's actually follow a single problem from the very beginning to the very end. We'll use a classic manufacturing headache, the kind of thing that could pop up on pretty much any line out there. And here's our problem for the day. A hole on a bracket is oversized by just a tiny bit, 0.3 millimeters. But look at that, 45 out of 200 parts are bad. Now, what's your first instinct? Probably to just scrap the bad parts, maybe tweak the machine and move on, right? Wrong. The first, and I mean the most important step, isn't to fix it, it's to formally capture it. Because listen, if you don't write it down, it's like it never even happened. And I guarantee you it is going to happen again. And that's where your first responder shows up. But it's not a person in a uniform, it's a document, the Engineering Problem Report, the EPR. I want you to think of the EPR as like the official police report for a quality problem. Its entire job is to make sure that nothing gets overlooked. Nothing gets forgotten. It creates this formal, traceable, auditable record for every single issue, no matter how small it might seem at first. So, the EPR has its own life cycle, right? And the most critical steps right at the beginning are documentation, you got to get all the facts down on paper, and containment. And containment means right away you are quarantining all suspect parts. The number one priority is to secure the scene and make absolutely sure the customer never, ever sees this problem. Okay, so the EPR has done its job. The problem is contained, the bleeding has stopped, so to speak. Now we're at a crossroads. We have a decision to make. Do we let the first responder handle this on their own? Or do we need to call in the specialist detective team for a full-blown investigation? And this is basically your cheat sheet for making that call. Did you get a customer complaint? Is this thing happening over and over again? Is the root cause a total mystery? Is it a major or critical defect? If you answer yes to any of those, you escalate. You call in the detectives and launch a full 8D. But, if it's just a one-off minor thing with a simple fix and an obvious cause, the EPR by itself is probably going to be enough. So, for our oversized hole problem, let's say the root cause isn't obvious at all. We gotta escalate. It's time to launch an 8D. And this is a really, really crucial difference, so listen up. The EPR is a document. It's a form you fill out. The 8D, on the other hand, is a deep dive process. It's a whole methodology that brings together a cross-functional team. We're talking experts from quality, engineering, production, all in one room to solve this problem for good. Now, yeah, there are 8 formal disciplines in an AD, but you can really boil its core mission down to these key things. First, you get the right team together. Then you find the true root cause, not just the symptom that's staring you in the face. After that, you pick a fix that is permanent. And then, this is the masterstroke. You design a system to prevent this problem from ever happening again, not just on this machine, but anywhere. So, how in the world do you find that true root cause? Well, one of the most powerful tools in the AD toolbox is the 5 whys. Let's walk through it with our oversized tool. We ask, why is the hole oversized? Because the cutting tool was worn. Okay, why was the tool worn? Because it wasn't changed on schedule. Well, why wasn't it changed? The operator wasn't alerted. Why was there no alert? The tool life counter wasn't set right. See where this is going? Finally, why wasn't it set correctly? Because the procedure doesn't require verifying the counter reset. We just peeled back the layers of the onion and found it. It wasn't the tool, it wasn't the operator. The true root cause was a flaw in the system. That's what we need to fix. But wait, there's more. The 8D asks a second, absolutely brilliant question. Why did we find this defect at the end of the line? This is called the escape point. It forces you to find the failure in your detection system. So it's not just about what went wrong, it's about why you didn't catch it way, way sooner. All right, so we've got the EPR, our first responder, and the AD, our detective squad. Now, the key to building a truly world-class quality system is realizing that these are not two separate things. They are two halves of the very same investigation. And this quote right here, this is the golden rule. Seriously, every field that overlaps between the EPR and the 8D has to say the exact same thing. The problem description, the containment, the root cause, all of it. If those two documents contradict each other, your whole investigation has gone seriously wrong. And this table shows you exactly how they link up, mechanically. The stuff you capture in the EPR at the very beginning, like the problem statement in Section 3, that feeds directly into D2 of the AD. The containment actions from Section 4 become your D3. It's one continuous story, just told across two different formats. You could say the EPR asks the question, and the AD provides the deep, detailed answer. Okay, and this next part, this is where we separate the good quality systems from the great ones. It's all about moving beyond just putting out today's fire to actually fireproofing the building for tomorrow. And here is the most common mistake people make. They confuse containment with the real fix. I love this analogy. Stopping the bleeding is not the same as healing the wound. Think about it. Sorting through a bad batch of parts, that's just stopping the bleeding. It's containment. It's super important, you have to do it, but it is not the cure. The permanent corrective action, the one that comes from your true root cause, that's what actually heals the wound. And this brings me to maybe the most important point of this whole thing. The most skipped step in almost any AD process, it's D7, prevent recurrence. This is the step that makes all the difference. This is where you actually update your procedures, your control plans, your training manuals. It's where you take the lesson you learned from one little oversized hole on one bracket and you apply it across the entire factory, preventing a whole family of similar problems from ever even being born. So at the end of the day, what's the big takeaway? The EPR and the ADD, they aren't just about filling out paperwork or following some rigid process. No. They are the tools you use to build one single, cohesive, intelligent quality system. A system that doesn't just run around reacting to fires, but one that actually learns from every single spark to become stronger and more robust. And so that's the question I want to leave you with. Think about your own process. When a problem hits your floor, is your system just reacting, just putting out the fire? Or is it truly learning how to prevent the next one from ever starting? Because that difference, well, that's everything.